Today we are going to discuss about buffer equation. The buffer equation is also known as Henderson Hasselbalch equation. Buffer equation is also known as Henderson Hasselbalch equation. So before going to derive the buffer equation, we should know what is meant by pH first of all. Okay, so pH means the negative logarithm of hydronium ion concentration. So already we have seen that. Now coming to the buffer equation. What are buffers? So buffers are the substances which are added to make the solution resist from the change in the pH. Okay, so we are preparing various kinds of dosage forms. Okay, the dosage forms which are in liquid state, there are high chances for altering their pH values. Okay, for example, if the given pH value is said to be alkaline, but it is changing towards acidic, or else the given dosage form should be acidic in nature, but it is tilting towards alkaline in nature. So in either of these two steps, we have to add the buffers. So the buffers in such conditions, they will be making the dosage form as per the required pH of the dosage form. So buffers are the substances which are making the solution resistance towards the changes in the pH values by means of either adding the acids or the bases. So that is the definition for a buffer. Now we will see how we can derive this Henderson Hasselbalch equation, which is also known as buffer equation. So for this we have to take either a weak acid which is reacting with water, and what will happen we have to see. Now we are considering acetic acid as the weak acid here. So whenever acetic acid is added with water, is reacting with water, it will give hydrogen ion and sulfur. Okay, this is the first equation in the buffer equation, which is also known as Henderson Hasselbalch equation. So after the first step, we have to go for applying mass of action. We have to apply law of mass action to the equation number 1. So what does law of mass action defines? Okay, according to law of mass action, the rate of a reaction is directly proportional to the concentration of the reactant products. According to the law of mass action, the rate of a reaction is directly proportional to the product of reactant concentrations. So here the reactants are CH3COOH, acetic acid, and the water mainly, and then the sulfur. So these are the three reactant concentrates in the equation number 1. So we have to go for getting acidic dissociation constant, which is represented as Ka, acid dissociation constant. So equals to, after applying law of mass action to the equation number 1, the equation will now becomes we can consider this equation as equation number 2. Okay, now always we are focusing on hydronium ion concentration to get the pH, right? Because pH is the negative logarithm of hydronium ion concentration. So take this H3O place aside, and how the equation will change now. H3O plus multiplied with, we have to take this aside, means it will automatically come as a product Ka into CH3 COOH plus This will come over here and CH3 COO minus will be in the denominator part. Cross multiplication. If you are taking this H3O aside, it will become Ka into CH3COOH. Okay, so in the next step, this CH3COO minus will come to the denominator part. So Ka into CH3COOH divided by CH3COO minus. So up here clear, right? First one we have taken weak acid, acetic acid. When it is reacting with water, we are having the first step. After applying law of mass action to the equation number 1, according to law of mass action, what is the equation? The rate of a reaction is directly proportional to the product concentration of the reactants. Okay, so by applying that law of mass action, we are getting equation number 2. Now we are taking hydrogen ion concentrations apart from the equation 2, and automatically equation number 3 will come like this. Here. Now we are seeing on the right hand side, in the numerator we are having CH3COOH, which is acid in nature. It is slightly ionized, so we can consider CH3COOH as acid. And in the denominator we are having CH3COO minus. It is completely ionized, so we can mention it as salt. So equation number 3 can be written as H3O plus equals to Ka acid divided by salt. Understood? Now we have to go for applying negative logarithm on either side of equation number 4. We have to apply log on both left hand side as well as the right hand side. And also we have to go for changing the sign. Means positive is negative, negative is positive. So the equation now becomes minus log H3O plus equals to minus log Ka minus log acid by salt. Consider this equation as equation number 5. Understood? So up to here clear, right? After applying law of mass action, we are getting equation number 2. We have to take hydrogen ions apart and you will get equation number 3. Then we know CH3COOH is the slightly ionized part and can be mentioned as acid, whereas CH3COO minus is completely ionized and we can mention it as salt. Okay, after that we are applying log on both left and right hand side of the equation and we are changing the signs completely. Plus means minus, minus means plus. So the equation number 4 will becomes now equation number 5 minus log H3O plus equals to minus log Ka minus log acid by salt. Now what is the equation of pH? pH is the negative logarithm of hydrogen ion concentration. See, negative logarithm of hydrogen ion concentration. So we can mention pH equals to minus log Ka means pKa. Minus log Ka is pKa. Okay, if you are writing minus log A by B, that is equals to log B by A. Okay, so we can mention plus log salt by acid. This is equation 6, which is called as buffer equation or Henderson Hasselbalch equation. Clear? So buffer equation is also known as Henderson Hasselbalch equation. Here we have to take a weak acid like acetic acid. When it is reacting with water, you can see what happens in the equation number 1. We have to apply the law of mass action. According to the law of mass action, the product reactants is directly proportional to the rate of reaction. So by applying that, we are getting equation number 2 like this. After that, we have to take the hydrogen ion apart. So we are getting equation number 3. Then we are going to apply logarithm on both left and right hand side, and then we are changing the signs. Positive means minus, minus means positive. Please. Okay. Then we are getting equation number 5. So in equation number 5 we are having minus log H3O plus. that is equals to pH, because pH is the negative logarithm of hydrogen ion concentration. So we are replacing this with pH, and minus log Ka is nothing but pKa. So we are writing that, and according to minus log A by B equals to log B by A. So we are making plus log salt by acid instead of minus log acid by salt. So equation number 6 is considered as buffer equation or Henderson Hasselbalch equation. Thank you.